Normally, when you need loops, you can use three forms of loops. Number one, you can repeat a set of instructions while a condition is true. This is the first form of loop. Really easy. So let's see the examples. Okay, let's see this example. We're going to solve this statement. The objective: read two numbers and show all the integers between the smallest and the largest. First step, the semantic analysis. Two numbers, we have to write what does two numbers means. So all the integers and between the smallest and the largest. So we're going to write the semantic analysis. First, two numbers. What does it mean? Simply, two values. Okay? All the integers. So what are integers? Integers are numbers without decimal point. And of course, without decimals. Okay? And now, between the smallest and the largest means a range of values where the begin of this range is the smallest number and the end of this range is the largest number. Okay? Remember, if you understand this semantic analysis, you can say, I understand the objective, the statement. Now let's see the IPO analysis. IPO means input, process, and output. Three parts, and here we are. Input. You can read in the objective. Read two numbers. So you need two numbers, of course. Then you have to read two numbers and store the first number in a variable and the other number in another variable. So the instruction is read N1 and 2. These are the names of the variables. I choose the names. And that means you read the first number, you store in N1. And the second number you store in N2. Okay? So the process. We are going to use the loop while. Then we use another variable. The name aus. Aus begin in N1. And you say while. Look, while aus is less or equal than N2, then you write aus, write in the display of your computer, and then aus is equal aus plus 1. Then this is the end of this while. Okay? And what is the output? The output are the numbers from N1 to N2, including the extremes. Okay? The IPO analysis is the algorithm divided in three parts: input, process, and output. Now let's see the call test. Remember, if you need to do the call test, you have to write place for the memory, or the RAM memory is the memory of your computer, and place for the display. Okay? Now let's see. In the memory, in the RAM memory, you write the variables. So in this program, you need variables N1, variables N2, and variable hours. Okay. Step number one, read N1, N2. That means read one number and store in N1, then read a second number and store in N2. Suppose you read number 3 and number 6. So N1 stores 3, then N2 stores 6. Step number 2, aux is equal to N1. So aux is equal to 3. Okay? Now, while aux is less or equal than N2, that means while 3 is less or equal than 6. First, write aux. Aux stores 3. And aux is equal to aux plus 1. So aux stores 3, then now plus 1, aux is equal to 4. And while, so you go into the condition. While aux less or equal than N2. Okay? That means 4 is less or equal than 6. The answer is true. So write aux stores 4, and then aux is equal to aux plus 1. 4 plus 1 is 5. Then and while. So you go to the while instruction. While aux less or equal than N2. That means while 5 less or equal than 6. The answer is true. So write aux. Aux is equal to 5, and then aux is equal aux plus 1. 5 plus 1 is 6. Okay? And while. So we go to the while instruction. While aux less or equal than N2. That means while 6 is less or equal than 6. The answer is true. So write aux, write 6, and then aux is equal to aux plus 1. So 6 plus 1 is 7. And while, we go to the while instruction. While aux is less or equal than N2, 7 is less or equal than 6, that is false. So the output, you can see in the output, you receive first two numbers. First number is 3, second number is 6. And then you can see in the display 3, 4, 5, and 6. These are the numbers between the first number you read and the other number you read. So the question, did you reach the objective? The answer is absolutely true. Now let's see the second statement. So the first we have to do is semantic analysis, the objective. Read a number and show its respective multiplication table. So we need to define what is show in the terms of the computer programming and what is a multiplication table. Okay? So show is put data in the display of your computer. This is show. Multiplication table is a format. It is a format where you write the results to multiply a number by all the numbers between 1 and 10. This is a multiplication table. If you understand the semantic analysis, you really understand the objective. If you can't understand the semantic analysis, you didn't understand the objective. And it's impossible to make a program if you don't understand the objective. Now, let's see the IPO analysis. First, input. Step number 1. To see the objective, read a number. That means you need first a number, of course. Step number 1. Read a number and store in variable named num. This is a name I choose for this variable. Process. Step number 2. We're going to use a variable aus. Aus begins in 1. Step number 3. While aus is less or equal than 10, write num, the content of num, the symbol x, the content of aus, the symbol equal, and the result to multiply num by aus. Okay? Like a multiplication table. Then aus is equal to aus plus 1. And y. And y. Okay? So the output is the multiplication table of the variable num. Now let's see the call test. Remember, in the call test, you need a place for memory, your RAM memory, the memory of your computer, and your display. You write in the RAM memory the variables. So we need to write num and aus. And the display. First step, read num. Suppose you read number 4. So the number 4 is stored here in variable num. Okay? Step number 2. Aus is equal to 1. So aus is equal to 1. While step 3, while aus is less or equal to 10, that means while 1 is less or equal to 10. That is true. So write the content of num, that means 4. The symbol x, the content of aus, that means 1. The symbol equal, the content of the result of multiply num by aus. That means 4 by 1 is 4. Okay? Then aus is equal to aus plus 1. 1 plus 1 is 2. And while. So you go to the while instruction. While aus is less or equal to 10. That means aus is 2. 2 is less or equal to 10. The answer is true. So you write the content of num, the x symbol, the content of aus, the equal symbol, and the result to multiply num by aus. That means 8. Then aus is equal to aus plus 1. 2 plus 1 is 3. Then while you go into the while instruction, while aus is less or equal to 10. That means 3 is less or equal to 10. The answer is true. So write the content of num, that is 4, the x symbol, the content of aus, that is 3, the equal symbol, and the result to multiply num by aus, that is 12. Then aus is equal to aus plus 1. 3 plus 1 is 4. Then and while. This process will be repeated several times. Suppose we are in aus equal to 9. Suppose we are there. Then we are in the instruction number 3. While aus is less or equal to 10, 9 is less or equal to 10, the answer is true. So write the content of num is 4, the x symbol, the content of aus is 9, the equal symbol, and the result to multiply 4 by 9. Okay? Now, aus is equal to aus plus 1. 9 plus 1 is 10. And while, that means you go to the while instruction. While aus is less or equal to 10. That means 10 is less or equal to 10. Right? The content of num is 4. The x symbol, the content of aus, the x, the equal symbol, and the result to multiply num by aus. That means 40. Then aus is equal to aus plus 1. That means 11. And while you go to while instruction, while aus is less or equal to 10, is 11 less or equal to 10? That is false. So the program ends. What is the result? The output, you can see, is the multiplication table of no. Did you reach the objective? Yes, of course, you reached the objective.